8.1 Points, Lines, Planes, and Angles. Basic terms. A point, line, and plane are three basic terms in geometry that are not given a formal definition, yet we recognize them when we see them. Point and line. A line is a set of points. Any two distinct points determine a unique line. Any point on a line separates the line in three parts, the point and two half-lines. A ray is half-line including the endpoint. A line segment is part of the line between 2 points including the endpoints. So these are descriptions of each, diagrams and symbols. So a line, here we have line AB, and that's how we would write it as a symbol. We have ray AB, so it's kind of like a line, but it doesn't have that second little arrow to connect it forever, so it's ray AB. Ray BA, you see how it's going B to A, so that's ray BA, and then line segment is just a piece of it, and we would say segment AB. Plane. We can think of a plane as a two-dimensional surface that extends infinitely in both directions. Any 3 points that are not the same line, non-collinear points, determine a unique plane. So this would be a plane, that's what it looks like. 2 lines in the same plane that do not intersect are called parallel lines. A line in a plane divides the plane into 3 parts, the line and 2 half planes. So if you have a line that divides a plane, you actually have 3 parts. The line and then the 2 halves. 2 planes that do not intersect are called parallel planes. Angles. An angle is the union of 2 rays with a common endpoint. So here is what we have as an angle. So we have your initial side that doesn't move, your terminal side which makes the angle, the vertex is where it all meets. The vertex is the point common to both rays. The sides are the rays that make the angle, and there's several ways that we can name this angle. We can name this angle B because that's the vertex. We can name it angle ABC because it goes in order, ABC. You could also name this angle CBA, so it just goes in order, CBA, ABC, or you can name it by just the vertex. Do you notice they both have B in common? So you can just say angle B. The measure of an angle is the amount of rotation from its initial side to its terminal side. Angles can be measured in degree, radians, and gradients. Angles are classified by their degree measure. Right angles have a measure of 90 degrees. Acute angles have a measure less than 90 degrees. Obtuse angle has a measure greater than 90 degrees but less than 180 degrees. Straight angles have a measure of 180 degrees. So here is each example of each of them. A right angle, we know what that is. It can be symbolized by that little box or saying it's 90 degrees. Acute angle is between 0 and 90. Obtuse is between 90 and 180. And a straight angle is a line, and it's 180 degrees. Types of angles. Adjacent angles. Angles that have a common vertex and a common side but no common interior points. Complementary angles. 2 angles whose sum of the measure of angles is 90 degrees. Supplementary. 2 angles whose sum of the measure is 180 degrees. You might remember those 2 terms from geometry class. Alright, alternate interior angles are interior angles on the opposite sides of the transversal. So transversal, these words might be coming back to you from geometry. This is the transversal. It's a line that cuts parallel lines. So alternate interior angles are just that. They're alternate, but on the inside. So 3, 6, and 4 and 5 are alternate interior angles. Alternate exterior angles are exterior angles on the opposite sides of the transversal. So again, we have the transversal. So they're like alternate spaces. So 1 and 8 and 2 and 7 are alternate exterior angles. Corresponding angles are 1 interior, 1 exterior on the same side of the transversal. So here's our transversal. And corresponding angles, do you notice our parallel lines in blue? They're like in the same position, top. If we want to do other ones, so that's 1 and 5. 2 and 6 are also 3 and 7, and 4 and 8. So 4 and 8, you see how that's the bottom of the parallel line? Bottom of the parallel line. They're like in the same position. Alright, descriptions. So we have line AB half line, ray AB, ray BA, line segment AB, open line segment AB, and half open line segment. So go ahead and pause the video and look at each diagram and the symbol for them. Alright, we're going to practice this again, but with some more stuff here. Alright, so we have a picture, a figure. You don't need to know what that is, but it's a figure. Alright, let's draw it out first. So you might have to pause the video and copy this figure 4 times. Copy it 4 times, pause it, and then come back. Alright, so we have ray BC, so B to C, and that's a ray. And then we have ray BG. And we want to union them. So if we union them, that means put them together. So when we put them together, do you notice it creates an angle? It creates an angle. So we can name this a few things. We can say that's angle GBC, goes in order, or angle CBG. And do you notice they all have B in common? You could also say angle B. All 3 of those are the same exact thing. Alright, I can erase. If you have a Surface or an iPad, you can erase as well, but that's why I had you copy 4 of these diagrams. If I didn't put it in there, I honestly can't remember. Let's do part B. Alright, so part B, we have ray AB. So AB, and it's a ray. And then we want to intersect it with ray CB. So CB, and it goes this way. Now, where do they intersect? What do they have in common? They have this in common right here. That's where it intersects, and that's a segment. So we say segment A to C. Segment AC. Alright, part C. We have ray BE. So B to E. We have a ray. And then we want to intersect it with ray BF. So BF. So B to F. Now, where do they intersect? They only intersect at this point right here, which is just a point B. That's not an angle, because we want to know what do they intersect. Not union, intersect. They intersect at B. Alright, part D. Part D, we have angle DBG. So DBG, and that's an angle. And then we have angle ABD. So ABD. And we want to know where do they intersect. So they actually intersect the pink meets the green right here at this ray. So it's actually ray BD. Determining complementary and supplementary angles. In the figure below, we see that ABC is 31 degrees. Let's determine CBD and CBE. So first we're going to determine CBD. So we have to figure out what that is. CBD. So we want to find this right here. That whole picture, this whole picture, that's a 90-degree angle, meaning it's complementary. So we know that these two angles put together is 90 degrees. We don't know this missing angle, so we say it's x. But we know x plus 31 degrees is supposed to equal 90 degrees. So let's just solve for x. We solve for x how we always solve for x. We subtract 31. And when we do, we get 59 degrees. So this angle right here is 59 degrees. Alright, now we want to find angle CBE. So CBE. I want to find this angle right here. This whole thing. So the whole thing itself is supplementary. EBA is a supplementary angle. Supplementary is 180 degrees. So we know the whole thing is 180 degrees, and what we know is that little piece is 31 degrees. So 180 minus 31 degrees, and we get 149 degrees. The figure shows two parallel lines cut by a transversal. Determine the measure of all the angles. Okay, here's a key word for you, parallel. Parallel in math actually means same. They never cross. It's because they have the same slope. So same means we're going to have a lot of the same answers. And what we're going to do is we're going to use this chart to find our missing angles. So we're going to use alternate interior angles, alternate exterior, and corresponding angles. There's something on that chart that we did not put. It's when they share the same vertice. So sharing the same vertice, see how we have an angle here of 52 degrees? That means directly across from it is also 52 degrees. Alright, then we can use all of our other information, alternate interior, alternate exterior, all of those types of angles to figure out what's missing. So we have angle 6 is 52. If we look, see how this is on the top of the parallel line? That means on the top of the parallel line is 52 degrees. See how they share the same vertice? That means this is 52 degrees. Now, if you don't know where to go from here, find another angle. You're missing angles next to it. You see how these are next to each other? They're always supplementary. So we can say 180 minus 52. And we get 128 degrees. So angle 1 is 128 degrees. You see how they share the same vertice? That means this is 128 degrees. Alright, we have alternate interior angles now. 3 and 5 are alternate interior. That means this is 128. And you see how they share the same vertice? So this is 128. You see how they're all the same numbers. There's only two numbers and they all share them. That's because of the word parallel.